Alright, so last day we have just discussed around the another ecosystem project that's on Apache Hive, and we have just saw the installations on Apache Hive on Hadoop cluster, and so we are just here to do a little bit of quick demos, writing the Hive QL queries, how to create the external tables, and some little bit of demos on the different types of tables on Hive, like external tables, internal tables, and regarding um, the partitioning concept on Hive, just to have a little demo that how to move data from one Hive table into another Hive table, one of which is partitioned, another which is non-partitioned table. So how to move the data between from a partitioned table into a non-partitioned table. So that's the couple of things that we need to cover. So let's first start today with building of an Hive table that's built on the stock data. So let me first create the table, and after this we will be moving towards the demo on Hortonworks cluster, and we'll be working on building some interactive queries on Hortonworks Hive tables, also using another package that's called Tez, Apache Tez, and we'll be watching that how the query engine that's being moving up more faster compared to MapReduce instead of using Tez on Hortonworks Hive. So let's first complete the Apache Hive demonstration, then we'll be jumping into the Hortonworks demo. So I'm creating a table, external table. So these are the schemas of the table, Hive table that I'm creating. And the table has a partition. So the partition column is stock date. So I've just created the table. Now the next step is to load the data into the table. So the command to load the data into Hive table, so I have the data file in my local drive. So the data file is present in this directory, that home downloads Hive. And the sample data text file I'm importing into the Hive table. Since it's a partition table, so I need to mention the partition column as well with the partition value. So the data has been loaded into the Hive table. Now I can see by writing a sample query. So this is a sample query that I have just written to check the data that's being loaded into the Hive table, and then just to perform an analytics over the table. So once I execute the Hive table query, I'll be able to see that a couple of MapReduce job has been started to run over there, and I'm able to see that the output is came up by execution of the MapReduce job. So these are representing that's the corresponding stock symbol name, the stock price, opening price, stock open price, stock high price, stock close price, and also the corresponding stock date. So since we have just worked in the sample set of data, so we have basically a little bit of data that's been available for the corresponding stock traders like Amazon, Apple, from these of these vendors. So in real time, whenever we work in real time data, the data are huge in volume, and since the queries would also take a little bit of time due to the processing of the MapReduce engine for the in the backend. So to overcome on this, the execution, to more about on the parallel processing and to execute the queries more faster, there is a new framework that is being evolved that's called Apache Tez. So whichever right now in Hortonworks platform, it's integrated with the Hive framework. So another demo we can also see that's on Apache Hive. So it would be based on creation of the two different tables. One table would be partitioned, another table would be non-partitioned, and in the partition table we will be moving the data, we'll be loading the data, and then on creation of the non-partition table we'll be importing the data directly from the partition table. So for that reason, first we need to create a schema, and the data set that we will be using for this next query, that will be from my airline data set, and the data set is available to me right now offline. So first I'm creating a schema as named as STG underscore airline, and now I'm going to use the schema in the table definition. Now I can start to create the table first. Since the data is huge, we have basically a huge schemas. Not much. That's around 18 to 20 schemas are there for this table, and the data has been taken real time from the data set of airlines data. So the table is created. Next, we intended to move the data. So I wanted to move the data that I have just taken up from the online retail airlines data set. So I'll be moving this CSV.
Hello.
Yeah.
Can we do DML statements here?
Yeah, we can do both DMLs as well as DDLs.
So, so how the data will store in the Hadoop environment? Is it dat files or?
It could be any of the files type. It's not specific, like it could be DAT file or CSV or TSV. It could be any file. So the data could be either in HDFS or it could be either in local drive. So if the data is already moved into HDFS, so in that case the data could be loaded into the table by using the command load data in path, the HDFS directory path, overwrite into the table. That's your Hive table. And if the data is, if suppose in local drive in the cluster, not into HDFS, so in that case, we can use this following command, whichever I utilized: load data local in path, the local directory path, and overwrite into the Hive table name.
Yeah, can we look into the where it is storing in the Hadoop structure cluster?
You mean the data is being storing, or in the Hive table is getting
Yeah,
stored?
the Hive table.
Hive tables is it's being the part of the ecosystem that where exactly in the Hive cluster itself the data is being getting stored, where each and every tables has been available. So in that cases, like without using Hue in Hortonworks, you could be able to see that what are the Hive tables that you have written, or what are the data that's been stored. That only you'd be able to see. But um, uh, for HDFS, just like within HDFS Explorer tool, you'd be able to see that what data have been there and all. Hive tables in such a way that it not be visible like this way, like whichever the tables. But if you go to directly into the Hue, and if you want to see that whichever the Hive tables that being written right now till now, that you would be able to see. But for that purpose, you need to use Hue, that Hadoop web interface in Hortonworks
But
platform.
how do we know? But how do we know this is storing in Hadoop cluster only?
Hive
But
always
Hive
works
is
on top of Hadoop. Without Hadoop, Hive would not be installed.
then that should be it should be somewhere it is located in the file path, right? In
That's not
Hadoop
my,
cluster.
that's why I have created the Hive home, right? Last day when I saw showing the installation type, so I have shown I think already I have shown that which is my Hive home path. That's user local Hive. For this cluster, it's being located in user local Hive. So in that is a Hive home. So there would be basically all the default structures, all the default configuration files that could be available, and also there
But
is a
when
Metastore DB would be available. Yeah, go ahead.
but in that path we can't see this all the DAT files or whatever structure files.
In that file, if you go inside this, okay, let me show you. So this is the Hive home path, right? That I have created
Mm-hmm.
as a default Hive home. Now in this Hive home, each and every configuration that's being available, that's inside the directory structure. Like since it's just a extracted path that I have just utilized for during the installation time. Now this installation that's being possible since already I have installed in this cluster Hive. Sorry, Hadoop. So as Hadoop HDFS, all the services are running. That's why the Hive Metastore has been installed, and that's why I'm able to write the Hive queries. Now, uh, in the Metastore, the corresponding drivers that's being also available, that by which I'll be able to perform this DML, DTLs, all these operations on Hive, and also anytime if I want to import export data directly from any other databases, RDBMS databases into Hive. So that's corresponding drivers that's being available over here. Now if you want to view corresponding the table, so that table in such a way, like you can only view the schemas for the tables, that whichever the schemas that you have applied, and that is something that's being available through H catalog. So H catalog is a component that handles those of the maintenance of the schemas that's provided in the Hive table. Is that answer your question?
Yeah, okay.
Okay. Okay, so the data has been moved into the one table. Now we need to create another table. So I've created another schema. So I've created two partitions. So now I've created just another table that's named as airline.ontimeperf, and this table has two schemas as a partition, that's year and month. Now I need to move the data from the non-partition table which I just created earlier, from that table to the newly created table. So I need to set the following properties. Since it's a dynamic partition, uh, it's there. So I'm setting first the Hive execution dynamic partition as true. Also, the partition mode would be non-strict mode. After that, I can directly go ahead with the insert overwrite query to move the data from the non-partition table into the partition table. So as we can see, MapReduce job has already started to execute, and once execution is completed, so the data would be moved from the non-partitioned into the partition table. So the data has been loaded into the new partition table, and of course we can visit the table after that partitioning, and after the data loading program. So all the data that's already moved from the non-partition table into this partition table. So this is some of the queries that we need to write in real time. That's for moving the data into a partition to a non-partition table, for creations of partitioning in Hive tables, partitioning, bucketing. Let's move into a quick demo on Hortonworks Hive to understand between the differences of the between the Hive and on Tez, and I mean basically the working principle of Hive and MapReduce and Hive and Tez, and what's the difference between them. I mean what sorts of difference has been created when we are working with normal Hive queries that's being in backend that's executioning a MapReduce job, and when we are using our Tez framework on top of Hive, and the Hive queries has been running on backend, the Tez working engine that's being processing. So let's quickly move over to quickly jumping into the HDP sandbox. So we'll be basically exploring in this demo some of the new features that Hive has came up in Hortonworks platform on Tez that's bring into the HTTP 2.1 and 2.2. So basically for this demo we need a working HTTP cluster, either sandbox or any cloud-based HTTP cluster. And we need to download some of the sample data set. So I'll be pointing out to the download the dataset itself, from which link that we need to download the files. And once we have downloaded, then we can start the executions of the demo. For in first demo, we would be performing the performance improvements of Hive on Tez on Hortonworks platform. Then in second demo, we'll be doing the performance improvement. Basically, we'll analyze the performance improvements of using the vectorized query, and then we'll be checking out in third demo some of the cost-based optimization plan, and then we'll be checking the multi-tenancy concepts on Hive Server 2 on Hortonworks HDP, and last we will be checking the SQL compliances improvements that's recently have introduced in Hive frameworks in HDP. So typically, as we mentioned earlier, that for HTTP 2.x, 2.2 or 2.1, the Hive framework version 0.14 has been using, and very soon they will be introducing the latest stable versions of Hadoop Hive package, that's 1.0, that's gonna introduced. So while the sandbox is starting, let me just quickly jump over a very brief overview on Hive and Tez. So first of all, that what is Tez and why it's so important today in Hortonworks Hive. Basically, Apache Tez is an extensible framework for building the high-performance batch and interactive data processing applications, which is coordinated by Airline in Apache Hadoop. So Tez is a framework which was released first as an Apache top-level project since in July 2014, and there are right now 16 Hortonworks committers who are working on this platform, on this particular framework, for improving and for coordinating latest new features on this particular framework itself. So the initial project page that's for Apache for Tez is being available on tez.apache.org, and Tez basically improves the MapReduce paradigm by dramatically improving the speed. So while maintaining the MapReduce ability to scale to the petabytes of data, since MapReduce, as I mentioned, while MapReduce job is typically slower because it's a parallel processing framework, and whenever we are working in real time for suppose petabytes or hexabytes of data, the job execution is very slow and it takes a significant amount of time to process the Hive queries. But Tez is one step improvement on top of this. So Tez not only works with Hive, it also works with Pig. And recently Hortonworks has introduced in the Hadoop ecosystem projects like Hive and Pig. They leverages this platform that's called Apache Tez as a growing numbers of the third-party data access application that's to be developed for broader Hadoop ecosystem. So Tez exactly provides a developer API and a framework to write the native Yarn application that bridges the spectrum of interactive and the batch workloads. So it also allows those of the data access applications to work with petabytes of data and over thousands nodes. So the Apache Tez component library, it typically allows the developers to work with um, uh, create the Hadoop applications that could integrate with natively with Hadoop Yarn, and they can perform well within mixed workload cluster. So as we defined that since with the help of Tez, we'll be able to perform basically as well as in the spectrum of interactive and batch workloads. So both with the help of SQL in Hadoop approaches. So actually it was a Stringer project. As a code name, and it was first started from April 2013 with the versions of Hive 0.13 when it was just a preview phase on Hive on Apache Tez. In that phase, the new feature that has been introduced, that cost-based optimizers, vectorized processing. After that, in next 6 months, they have introduced the new advanced data types for this approach, like the advancement of worker and day data type supports, ORC file predicate pushdown that's being added, and there are some advanced optimizations that's being introduced. And recently, last year, that in July 2014, they have introduced that as a public preview, and it has been integrated part of HTTP 2.1 onwards. It's being added. So, what was the initiative for this changer? Because it was being created to take in mind that to have a broad community-based effort to drive the next generations of Hive. The goal behind this for creating this particular framework is the speed was a major concern to improve the Hive query performance by 100x much faster to allow the more interactive query times over the seconds. Also to scale up the data because the only SQL interface was this to Hadoop that's being designed for queries that could scale from terabytes to petabytes. And SQL was a major platform because all of the developers are mostly familiar with SQL, so it has it has got its major support as a broadcasting range of all the SQL semantics for analytic applications running in Hadoop. Since Tez is an extensible and embeddable platform, so it provides the fit to purpose freedom to express the highly optimized data processing application, just being giving them an advantage over that end user facing engines such as MapReduce and Apache Spark. So Tez also offers a customizable execution architecture that allows users to express complex computations as data flow graphs, permitting dynamic performance optimizations based on real information about data and the resources that require to process it. So speed was a major concern, as I said. So that's to just to increase the Hive query performance over that. So it has got its interactive query times to be across all of the use cases. Typically, it's a very simple and advanced queries that we can write with the help of this execution engine just in seconds. It could help to integrate seamlessly with the existing tools and clusters. And currently, there has been got a 100 times a faster improvement that's being done in just in 9 months. There were some key highlights also. Like Tez was as a new execution engine because it's a de facto standard for SQL in Hadoop. So as we know that Apache Hadoop is optimal for both batch and interactive queries at petabyte scale, but Hive embeds the Tez so that it can translate the complex SQL statements into the highly optimized purpose-built data processing graphs that strike the right balance between performance, throughput, and scalability. So Apache Tez innovations drove many of the Hive performance improvements which has been delivered by the Stinger initiative. It's a broad community effort that's included the contributions from around 145 engineers across 44 different organizations, and so Hive basically helps make to Hive as a more interactive. Tez helped Hive to be made as more interactive, and Pig also being become more interactive with the help of this framework. So it was just got some of the elements for the faster SQL executions like query planners and cost-based optimizers with statistics. It has got a beautiful query startup execution engine. It has got a query typical a query execution platform which is to be more faster, and also it has got typical IO paths as well. So Stinger is typically an enterprise SQL platform at Hadoop scale, which is being typically a broader community for Hortonworks, and they recently delivered the Stinger initiative as the timeline. So the components that was included in their Stinger initiative for Hortonworks, that was base optimization, the SQL types, the SQL analytics function, ORC file modern file format, advanced optimization, SQL types, SQL analytics function, performance boost via Yearn, container pre-launch, container reuse, Tez integration, and in-memory cache. Now, in April, in April 2013, the final phase of initial Stinger initiative, the project was delivered on schedule, and this brought interactive SQL query that's to be on Apache Hive, advancing the Hadoop SQL capabilities at petabyte scale in pure open source platform. Over 13 months, just all of the engineers, they have worked together and they have contributed over 390 million lines of code to the Hive project, and the work has already got a tremendous impact on the entire Hadoop ecosystem. And in the second phase in 2014, last year, it has also got the next phase. It's got its next phase to be released up, and they have released the public preview of Hive over Tez and Pig over Tez. It has got the support of transactions with ACID property, allowing just insert, update, delete, and also it has got the temporary tables support, and it has got support on cost-based optimizer for star and bushy join queries. And in the second phase, which they are planning to release in first yearly quarter of this year, 2015, that could be included the sub-second queries with LLAP, Hive Spark machine learning integration that will be included, and operational reporting with Hive streaming, ingest, and transaction. And similarly, in the second phase, of this particular project which they are planning to deliver. That's basically that would be focused on rich analytics side. So that would be focusing on SQL 2011 analytics side also. That would include the materialized views, cross geo queries, workload management via Yearn, and LLAP integration. So this rich analytics phase of this project that might be released in the second quarter of this year. So it's there in future planning of Hortonworks. So typically, this entire project and this platform was based on the statistics enhancement, optimization, and a few of the goals that was being taken in mind. So statistics that's typically based on that the user, the Hive has the table and should have the column level statistics that could be available to the user. It could be used to determine the certain level of parallelism, to understand the joining selection. Since the entire platform was open source, the Stringer project was also open source. So Apache licensed query execution framework that was delivered in Java, and it was used initially by Apache Drill, Apache Cascading, and Lucent databases based on the Volcano paper. That was around 50 optimization rules that has been involved in that paper. Now, what was the goal behind this for this improvement for Hive? Basically, for ease of usage, like no manual tuning was to be required for queries. Manual choices, make choices that's automatically to be based on the cost, and there could be a view chaining purposes, ad hoc queries that could be involved in multiple views to help to enable the BI tools to be a more front-ending on Hive, and to emphasize more on the latency reduction, and also the cost computation that could be was a major milestone that to reach, like for join ordering, join algorithm selection, and Tez vertex boundary selection. So Stinger.next, that project that would be delivered at a rapid pace. Even the guys they are working on this, and over the next 18 months, they are thinking to plan a significant amount of releases to be come up for this platform. And the transactions will already released in the 2014 later time. Subsequent queries that's to be coming up in the first half of 2015, and with a preview of the next few months. There could be an initial outline that is to be delivered in this, right? And they are being expecting that the work that is to be completed with the rich analytics in the second phase of this year, which could be more focused on the rich analytics side, like materialized views, cross geo queries, workload management with Yearn and NLP integrations like this. So initially, what they have checked that for the TPC-DS query, initially the set of Hive queries, which that could be utilized to join the, suppose if we have been working on a sales database, a sales and transaction data set. So there have been a major joining that is to be performed over the data set, and there could be the joins between the store sales table, so store returns and catalog sales fact tables. Each of the fact tables that could be independently restricted over the time. Now, analysis for each and every item and the store grain, so that dimension could be also joined in, and all the specific query that's being started by joining the three fact tables, which was pretty much was a cumbersome approach that in case of processing time, in case of execution time, and also the scaling of data, because when we have been working over the tremendous vast amount of data, the processing almost is getting to be very slower. So in this, from this initial approach, whenever we have been moved into the new CBO plan, so the CBO plan actually it's being involved in this case, that's a cost-based optimization plan. Now CBO is actually that is being involved for the cost-based optimization engine, which uses a statistics within the Hive tables to produce the optimal query plans. And what is the benefits behind the CBO? That's the cost-based optimization. To reduce basically the need of a specialist to tune up the queries, so that no manual approach is not needed to tune up the queries for more efficient performances, and to more efficiently plan up the query to lead for the better cluster utilization. So as much as best query planning that's to be done, so that could be affect the optimizations of the cluster itself, the Hadoop cluster. So that was actually called as a CBO, and the planning for the cost-based optimization that's been called as a CBO planning. So typically, if we see that what are the types of statistics that's being delivered by Hortonworks in this respect, that there were actually two types of stats that could be collected so that optimizer could use that in the decision-making process. One of them was the table statistics, and another of them was the column statistics. So basically, there is a keyword called explain. So this explain keyword actually helps to plan the feature that could be used to see if the correct statistics are being utilized. So CBO also requires typically the columnar statistics. So if we just check that according to that the example, like for any of the sales transaction fact tables, which needs to be partitioned by day, and it needs to be also bucketed by item. So if the bucketed option is being turned off, so bucketed should help the CBO plan, the cost-based optimization plan. And SR table, if it is, suppose if it is much smaller, so better chances of the bucketed join that could place up in the shuffle join. So that's we could think of how to make the query optimization is to be more understandable and more approachable to apply the CBO benefits and the CBO plans over there. So Apache Tez, as I mentioned, that it is basically it's the name of the speed. Uh, exactly, it's just replaces the MapReduce as a primitives of Pig, Hive, cascading. So it's not only just works for only Hive, it works for other frameworks as well, and we can leverage a significant amount of processing speed, and we can be able to see that the how much lesser time has been needed when we are working on this particular platforms with Tez. So since it's a newer platform that has just been integrated, so its improvement over the data processing in Hadoop just extend well beyond gains the same in Apache Hive and Apache Pig. So Apache Pig typically works in a different model, like one of the model like which is called express model and execute processing logic. So Tez actually models first of all the data processing as a data flow graph, and with the graph vertices just representing the application logic and its edges represents the movement of data. So as a rich data flow definition API allows the user to initiatively express the complex query logic. So this API will fits well with the query plans produced by the higher level declarative applications like Apache Hive and Apache Pig. So typically for any Tez specific task, if we see it has basically a pluggable input, a processor level, and as an output level, and it typically works with a smaller latency for interactive query. There could be a higher throughput for batch queries, and there are right now around 22 contributors overall working, 13 from Hortonworks, and also contributors are from Facebook, Twitter, Yahoo, and Microsoft. They have been working together. Um, Also, to understand the difference between Hive on MapReduce and versus Hive on Tez. So, of course, we will be seeing the differences on the hands-on side, but to understand basically the difference between these two platforms, that the execution platforms of by these two, so we'll be able to see. Suppose we have been performing a query like group by clauses. So in MapReduce, how the chaining has getting to be differentiated across the running the different maps over the different reducers, and then after that reducers, the uh, shuffling and sorting phases, the data has been finally coming into the HDFS, and similarly for another group by, so the data from the maps is been coming out to the reduce phase, and from the reduce it's been coming out to the HDFS. Then again there is been a joining has been getting to be performed, and after joining there also a MapReduce job that's been running in behind. After the reduce phase, the data is again getting to be saved into the HDFS, and after that it's getting to be performed the order by clause. So in just in single line of Hive query, there is a significant phases that's being available over the MapReduce jobs execution. So if suppose some user has been writing this following query, like select uh, some of the schemas like g1.x, g1.average, g2.count from another query like another subqueries, and performing a joining operation. So and there is an order by clauses being available, and group by clauses has been inbuilt within the subqueries. So these are the following phases that's being available within that execution environment in backend. But the similar query, if it is being written and execution is being happening over Hive on Tez, so this could be a simplified vertices, just a directed acyclic graph that would be available. There is no intermediate storing on HDFS, and then again another set of MapReduce jobs. Nothing is being happening. Just a simple, speedy processes that's being running. which is being more optimized performance and over the greater resource management that's being available. We can be able to see in this graph as well. So dynamically, Tez also works on dynamically reconfiguration of the graphs. So as you can see, this graphs that's being the execution flow. So it works actually for distributed data. Processing has been dynamic, and it is difficult to determine the optimal data movement methods in advance. So more information that's been coming actually in runtime, so which may help to optimize the execution plan further. So actually Tez includes a support for pluggable vertex management modules to collect the runtime information and change the data flow graph dynamically to optimize the performance and resource utilization. Because Tez also avoids unnecessarily writing to the HDFS, which MapReduce does. It helps to optimize the performance and resource management because it uses actually Yarn, and Yarn actually manages the resources in the Hadoop cluster based on the cluster capacity and load. The Tez execution engine framework efficiently acquires the resources of Yarn like resource manager, node manager, app master, all of the resources it's been using, and reuses every component in the pipeline such that no operation has to be duplicated unnecessarily, which MapReduce doesn't take care of. And also, the exact API for Tez is being defining on the directed acyclic graphs on the DAG. So Tez defines a simple Java API to express a DAG for the data processing, and this API has three components. One is called the DAG, that's a directed acyclic graph, which defines the exact the overall job process, like from where the map processes has been starting, then in which phase the group by or joining clauses has been starting, then reduce phase coming up, then comes up for the another order by clause, another reduce job is being working. So let's enter a directed acyclic graph that defines the overall job process, and the user creates a DAG object for each of the data processing job. Then it also consists of some of the vertexes. So this vertex defines basically the user logic and the resources environments that needed to execute the user logic. The user creates a vertex object in each and every step. So as we can see that if we check in this diagram in this directed acyclic graph for the Tez execution, there has been the vertexes that are available for this execution. So that defines the corresponding user logic and the resources and environment that needed to execute the corresponding user logic, and user himself can create a vertex object for each and every steps in this job, and he can also add that to the DAG. And there are also some of the ages as being available, as we can see in the graph. So the age defines basically the connection between the producer and the consumer services. So the user, suppose if he creates an age objects and he wants to connect the producer and the consumer services, so he can do this by using this age services. And Tez also based on the concept of using like reusing the containers. So Tez actually follows the traditional Hadoop model of dividing a job into the individual tasks, so all of which are run as a processes via Yarn. So on the user's behalf, this model comes with the inherent cost of for processor startup and initialization, handling the stragglers, and allocating the each container via the Yarn resource manager. So these are some of the steps that to be performed while Hive queries works on Tez. And also we have been able to see that the differences when similarly a Hive query runs on the MapReduce paradigm. So if we check that the corresponding way that shuffle joins whenever it's been happening between Hive MR and Hive Tez. So for the shuffle joining cases, suppose suppose a user is throwing up the following set of queries, like selecting some data on analytics data from a table and performing some joining on that sets of the data. So for the Hive MR, when the shuffling join that's been taking up a randomized spaces and randomized manner that's from the vertices and edges that's been taking up and it's being running over there. So for Tez, as we'll be able to see, for the same set of queries, when it has been involving the data from inventory and the store cells. So just for an example, each and every individual module has been differentiated for the individual map task. So for MapReduce, whenever all the data set has been taken up into the same data in the same map phases module and it's been running in common, but in Tez, the data module has been differentiated so that each and every map task would be significant enough so that they could be able to handle the corresponding processing more faster. So the difference that's being easily visible that while the processing and execution of a query on top of MR platform and on top of Tez platform. And also, there are some recent progresses has been happening on Apache Tez. The earlier version was 0.4 in earlier 2013, which has an enhancement of application recovery and data shuffling optimization. In the current version that's been running for Hortonworks HDP, that's 0.5.1, which has got the support for a stable developer API. It has got support for running Tez in local mode as well, and it has got a swim lane UI tool. So a lot of new enhancement that's being done, and Hortonworks typically they are focusing for Tez because the current work in Apache Tez innovation that's also focusing on improvements to speed, scale, and usability, which includes the processes on granular counters, frequent updates, and improved recovery process. For another types of join, if we see the approaches between Hive MR and Hive Tables in case of broadcast joining. So we'll be able to see that the difference between these platforms over here are very clear differences. Like suppose a user is throwing the following set of queries for the analytics query over the sales and the inventory data, and so for the Hive MR, when the store sales the sales data is getting scanned and then grouped by an aggregation, that's been happening in one phase of chain of graph. And similarly, the another phase of executions like inventory, store, sales, aggregations of the data, output, scan, and shuffle join, that's getting to be happened in the second phase of execution. And in between both of these phases, we'll be able to see the data is getting stored in HDFS, and then the next levels of job is getting started. But in case of Hive Tables, if we see for broadcasting joining itself, the both of these stages like store the scales, data scanning, and group by operations, aggregation, reduce size. So the data is being in the back phases directly coming into the reduce phase, and from the reduce phase, data is moving directly into the next stage map phases again with the help of the broadcast stages. So there is no unnecessary HDFS saving data. No approaches is there. Unlike Hive MR approaches. So since the time it's getting much faster, speed is a major concern over here for this platform, and even the scaling of the data is also a pretty more important milestone for this framework. So that's why it has got for broadcasting joining cases. Tez works specifically a types of age that's called broadcast age, and with the help of broadcast age, we'd be able to see that there is no unnecessary data storing operation is there, and only once upon a time after the end of the inter execution, the data is getting to be stored inside HDFS, and in between there is no data saving options being available. That's why the framework makes the processing is to be more faster and to be a more optimal performance that's being available. So actually there are different types of ages being available for Tez. That's one of them is called a one-to-one age. So it's based on typical star schema join that's to be involving in this join between the large numbers of tables, and dimensions are not always tiny. Could be based on the customer dimensions as well. It might not be able to handle all the dimensions in the single vertex as the broadcast join. Tez also allows a streaming records from one processor to the next one via this one-to-one ages. There could be a transfer details like streaming files, etc. that could be handled transparently, and scheduling cluster capacity, it's also worked out by Tez itself. So the framework itself is capable to handle all of the capabilities. The granular counter which is being available for Tez and Hortonworks is focused on the specific module. There's some additional counters that could be available, including input and output counters to help the developers with diagnostics as well. And there is frequent updates that's being available for Tez, which this update comes as the job is being running to simplify the diagnosis of the jobs that could take longer than expected. And it has got also improved recovery process, like to reduce the amount of rework after failure, so that more granular checkpointing that's to be available. So Apache Hive, it's just being allowed platform on Tez to build a pipeline of in-memory joins so that developers can stream more and more records through this platform. And similarly, if we see the corresponding dynamically partitioned cases for hash join. So we'd be able to see that if suppose the following set of query has been thrown for partition hash join cases, and in that cases we'd be able to see in the map phase, while just only a single map process mapping phase that's been working and storing the data directly into the HDFS, and again after the inventory scanning process, when the stores sales data again gets scanned and it has getting joined through the map phases. So the data has been intermediately, it's also being storing in the HDFS, and a lot of intermediate steps that's been coming out over there. But for Hive Tez environment, we'd be able to see that there is a custom edges as being available for partition has joining cases of Hive, and the custom edge basically helps to route the outputs of the previous stage to the correct mappers of the next stage, and also it helps to to run on the cluster potentially on more than one mapper. So in running the data and performing the operation in one mapper, because it takes a significant amount of time, processing is much slower. But Tez platform optimally it helps to add another more than one mapper is being potentially added, so that the job execution would be more faster. It could be helps to integrate the cluster optimization, it could take care of, and also the enter operations could run on the custom edges, so that there could not be unnecessarily data movements would be there, and it could help to route the outputs of this previous MapReduce stages directly into the correct mappers into the next stages, and there would be no unnecessary data storage operations to be there into the HDFS. Just at the end of the enter process, the output data would be stored into the HDFS. So just it's an optimized framework, so that's why it has got optimized graphs, directed acyclic graphs that's being invented for this framework itself. And there is no side-by file reads operations being available while it's working on Tez platform. So if we see the differences, that could be similar to the map join, but for partition join, has join, the things are pretty much changing whenever the things are being working on MR and the Tez. So if I just take an example of bucket map join and the execution details between Hive MR and the Hive Tez platform. So for Hive MR, we'll be able to see there is no dynamically partitioned clusters. So it's not, and nothing is to be dynamically partitioned, but in Hive Tez, only one of the sites that needs to be bucketed, and all the other side that's being dynamically, I mean the other side is dynamically bucketed. Only one of the sites which needs to be bucketed, it's not dynamically bucketed. Other all the sites have been dynamically bucketed over there. And for Hive tables, for the MR execution, while both the tables that needs to be bucketed by the same join key, but in Hive Tez, that we'll be able to see that it also works by if neither side is explicitly bucketed, but if another operation is forced to bucket in the pipeline, so it could be able to perform on that. One of the major differences that for Hive MR platform, there is unnecessarily working operations on HDFS, which makes the platform operations to be much slower. But for Hive Tez, there is no unnecessary operations on HDFS, no writing on HDFS that's been happening in Midway. And also in MR side, the numbers of mappers for the join that must be same as the number of buckets. But in Hive Tez, due to the more optimized performance, there could be more mappers than the number of buckets, and the bucket can be processed in parallel along with the multiple mappers. So that's the improvements that's being done. Similarly, if we take an example of union all cases as well, so just for throwing up the similar query for union all cases, so we'd be also able to see the differences between the executions of both of these two platforms. So for MR platform, I'll be able to see that two MR jobs for this query execution that being running to do the distinct clauses. So after the mapping phases, after getting the reduce phase, the output is being getting to be working. Operation has to be save the data into HDFS for subqueries that's being materialized into HDFS. Then again, the single map just reads both the sides and aggregates, and the joining map and reduce phases being operationalizing over here. But on Tez platform, if the same query is just being running, so in Tez, the subquery output that's again have to be pre-aggregated, and it has been sending directly into the common final node. So no intermediate HDFS operations, no extra stages that's being available for Tez platform. Similarly, if we check for multi-insert queries as well, so a query that helps to do for the multiple insertions for the data, so from one table into the multiple tables. So here also for MR platform, so if we see that the map join, the data dimension, data store tables, that's meaning a lot of intermediate stages being available, a lot of time HDFS operations are being there in midway for saving up the data for intermediate data. After the mapping phase, again the data is being coming out into HDFS, and then again from the HDFS data has been moving to the further MR jobs, that for two MR jobs that's to be performed in the distinct MapReduce phases. But on the Tez framework, for the running of the Hive query, you would be able to see that simply it is being running on the broadcast join in the first phase. That's to help to scan up the data dimension data to join the store sales tables, and after that the data is being directly coming into the reduce phase for distinction to count up the total numbers of customer items, and finally the data has been storing into the HDFS system. So there is no unnecessary data movement, there is no unnecessary data operation, HDFS operations, and then taking out the data. So optimizing platform, so that's why it's been taking care of speed, data granularity, as well as the data scaling approaches. So actually this execution is a major plan that was being taken in mind, and that was the focus of Hortonworks itself, because a good plan valiantly it is to be executed now. It's better than a perfect plan executed next week. So it has been made into the mind for the faster query setup as well. So just for the per session instead of per query, so that it could be reused across all the JDBC connections for Hive. Could be no more local task except the fetching aggregation. Metastore fetches are much more faster compared to Hive. Hive Metastore actually being responsible for storing of data. So Metastore direct SQL fast path with the help of the Tez framework, it's just making of them to be much faster. Partitioning filters that's being pushed into the Metastore. User distributed cache is efficiently that is being utilized for Hive execution jar files. UDF jars are also works well. Yarn basically localizes these jars once per node, and also Cryo, it's a small framework that's being utilized to instead of XML to serialize operators. Cryo is actually the serializer deserializer engine that's being running on Tez on top of Hive, and it works better on the latest versions of JDK 7 onwards. So previously and recent versions of Hive execution details that is being depicted in the screenshot. Next comes up the operationalizing, vector operationalizing. So typically if we just to understand, try to understand that what is called the query vectorization. So vectorization typically is a process when the vectorization feature is utilized, it fetches 1,000 rows at a time instead of one for processing, so that it can process up to 3x faster, 3 times faster with less CPU time. So this results in improved cluster utilization. So it is to address the latency problem in Hive by extensive container use and reuse. So vectorization feature typically works on Hive tables with WRC file format only. So just to have to allow the efficient JIT code for primitive types, it could be generate the par type loops, and to avoid the runtime type checking cases, the classes generated that's to be look like for the vectorization is like this, like long column equal double column, long column equal long column, like this. And it's just being the framework has been taken up, so just to avoid the duplicate operations on repeated values. So it could be like include the following framework following keywords like is repeating, has nulls, like this. Hello, am I audible? Okay. Okay, so as I said, the vectorization, that feature that works on Hive tables with WRC file format, and since the vectorization feature was taken in mind just to avoid the duplicate operations on the repeated values, which could include the following terms like is repeating and has nulls. So the following keywords that could be utilized in the query while we are being applying the vectorizations on the Hive queries. So this is the format of the WRC files, that's optimized row columnar files. So it could be helps to leverage the WRC vectorized reader. It could be also utilized to provide the logical compression helps reader like is repeating features that's being included in the query body. And so if I'm being checking out the corresponding index data, row data, and stripe footer for this corresponding columns of data, so that's been clearly understandable that which of them columns that could be operationalized for the row data and which of the columns that could be operationalized for the index data. So logical compression here works as helps to reader. That's a is repeating process. That's is repeating is a keyword basically that's being applied here for WRC file format operations. So here is also available the row group level indexes. So each and every row groups that's being leveled as to build up the forming indexes, and there is also a PPD avoids that's to a lot of IO operations. So columns conditions are always and here. So we'd be seeing that the execution plan, the execution mode, vectorized mode in the hands-on, that how the features to be working and what are the query plannings being operationalized for this ORC file formats. There is some faster statistics also available for this. Like WRC typically strives the footers to aggregate stats per column. Typically, as I said, there are two types of statistics that are available for WRC format for the decision-making process. That's one is the table statistics, another is column statistics. There are different phases are also available in which the stats could be collected while the data has been inserted. So we need to mention as Hive stats autographer equals to true, and on existing data on the table level, so we can write analyze table name, partition of the key, and the compute statistics query. And for existing data for column level, like analyze table name, partition key, compute statistics for columns as column 1, column 2, like this. So the explain plan typically is a feature that could be used to see if the correct statistics are being used or not. And of course the CBO requires all time the column statistics. There is being predicate computation is being there, but without the Tez or immerse statistic task that works. Analyze table name that actually compute statistics partial scan. This query typically works to, and it reads only the WRC table footers. For faster execution for Tez, there are multiple H types as being available. So as for the broadcast shuffle, one-to-one joining purpose, multiple output types that could be there, like either sorted, unsorted, and unsorted partition. And pre-vertex configurations that could be available, that's to be instead of one configurations between the MapReduce task. Tez is basically for the I/O speedups operation. So Tez can shuffle, that can use the keep alive over HTTP phases. Shuffle scheduler can optimize the connection count, so it can fetch all the map outputs from one node via one connection, and it could be skipped into fetching the zero size partitions from the mapper. So it could speeds up to the group by queries with high locality values. Reducers finishes the shuffles to be much faster. Shuffle threads have to be reused in container to basically to emphasize the reuse principle. So that the user could secure the shuffle that has crypto thread local units over there. There are some skewed reducers are also available for just to enhance the auto parallelism feature. So often the queries are become slow because of one slow reducer. So in that cases, there are some skewed data which is too common in real life queries. This avoids the running too many reducers with very little data. So that feature is something called a skewed reducer for auto parallelism purposes. So it can be extended to group by input sizes, and this mechanism can actually speculate on scaling the reducer better. So that's called as a skewed reducer. And also there is multi-tenancy is being available for Hive server 2. So that could be the contentions when multiple servers run the large query simultaneously. In that case, processing the queries with many containers that could lead to the lower latency. So for this, suppose three controls could be put into the places like container reuse timeout, taste split wave tuning, and round robin queuing setup. So we can able to diagnose job viewer also, like Hive job viewer that is being available in Ambry, and we could be able to see the job viewers over there by utilizing to show that visualize the execution DAG. Drill down the individual stages, execution status, duration, number of bytes that has been read written, number of containers, and DAG viewer for Tez that could be it's already released with HDP 2.2, and it's available with Ambry itself. And they've been working on this for better enhancement. So probably next versions of HDP it could be more enhanced for Ambry portal. So just an example, suppose a query is in motion. So there are four ways for map join plus MapReduce reduce query. And if suppose the timelines are being left to right, so each lane that represents the one container and it represents the DAG execution phases for the corresponding MapReduce job phases over here for the query. Similarly, we would be able to check the skip or defer task. So no more uploading of the Hive execution jar or UTFs for every query that's being needed. No more spinning up of aims for each and every stages that's being needed, and no more computations also is being needed on the Hive client as on the local task. Concurrency is to be it's a great enhancement is being done. So Hive is typically used to run the several lightweight tasks on the local VM. Local task was a bottleneck because there was no locality, no parallelism, and small VM. So Tez actually utilizes the broadcast stages to solve the problem. So that to leverage the concurrent split generation, basically Tez input the initializers to be run in parallel. No more spinning off of the aim is needed for each and every stages, and no more computations on the Hive client that's also being needed as a local task. So for faster processing and optimized performances. It also helps to split the eliminations like WRC files which comes to the predicate the push down into the reader, queries with the surgable where the clauses, runs the sargs in the aim, so with using the WRC footer data to eliminate the splits before the task spin-ups, avoid the container cost. It also offers a soft cache for the WRC footers itself. Pipelining splitting for the task is also available. Like the task which only depends on its own input, it starts to talking with Yarn directly once its inputs are ready, so that the inter-job operations that's being take care with the help of leveraging the Yarn clusters and resources and processes. Faster generations of the dimension tables that's being capable of, and fast fact tables can optimize also for this on this further. So if we check that for filling up the pipeline cases, like Tez allows for grouping the splits dynamically. It also obsoletes the combined file input format. It grouped according to the locality-based format. Like in Ambry 1.7 onwards, there are some available containers as being there for Hive containers, and it allows the query to use up to 100% of the queue capacity. So without tuning the map rate split sizes for each and every datasets, so user would be able to see that in your local VM that if the Ambry is being turned on, so what was the utilizations for the corresponding maps and the reduced task over a VM for the corresponding execution for this entire query operation. So this execution cycles would be also available to see on this Ambry and Hive server jobs portal. For a WRC split extract, so basically the WRC file, RC file has an horrible split performances because since it is a columnar based format, and WRC reader also allows to exact the splits for the stripes. WRC writer can also pad a stripe to an HDFS blocks. There are actually 5% to 7% overhead that's being measured on the table, and 100% locality that could be available of a stripe in a particular block. So you'll be checking in the hands-on that how exactly the WRC files is being handling the query vectorization, and we'd be also able to see that what are the cost-based planning that's being available on WRC. So that will be checking. For container using principle, because Tez has a very specific feature that it can help to run an entire directed acyclic graph, a DAG, using a same container, so that different vertices that could use the same container, and it also in this way saves the time talking to the yarn for the new containers itself. Tez also provides an object registry within the vertex. This could be used to cache the map site map join hash tables itself, and JVM GIT kicks off that's to optimize for the better using principles of containers. Container using, like just to keep a container, a group that's to be alive in between the queries, fast query that spins up and skip the high yarn queues, and even better GIT performance that's to be available on greater than one queries itself. Hive Server 2, so as I mentioned that in Hive Server 2 onwards we have a multi-tenancy that could be predictable over there. Typically in the multi-tenancy there could be like it could be better in the place that's to understand the job viewer diagnosis, like Hive job viewer that's being available in Ambari for simple exploration and troubleshooting cases for graphical tools of Hive jobs, and for processing query, suppose with too many containers, that could lead to sometimes a lower latency. So that's why for Hive Server 2 onwards, 3 controls that's being added to put into the place for the container reusing timeout cases, when Tez splits the wave tuning cases, and round robin queuing setup. So it's typically idle for short exploratory queries. A new security model that also helps to secure the queries to run as basically Hive user, and Hive Server 2 can also keep those sessions to be alive between the different JDBC queries. So whenever the users are performing connections through the JDBC drivers in between the RDBMS tables and the Hive tables, so in that cases they don't need to open each and every time the JDBC connections for importing, exporting data and all. So just keep up the sessions. Hive Server 2 can help to keep the sessions alive. So just to supersize it, that's over 878 vertexes can run over 8,374 tasks alerts, over 50 containers over the time on Hive Server 2 using Tez over HDP platform now. For query overloaded cases, like just suppose 5,000 Hive query has been already set, only 3.9K triggered compute task has been tested. Rest was optimized away into fetch task or metadata task, and it has been progressively gets faster as the JVM GIT improves over the native code performances. So big picture, latency was basically a big pictures over the time. So suppose for the general case of the text-based Hive tables, while latency comes to be measured as more than 1,500 seconds. So for the columnar table, while latency to be compared as to be more than 1,176 seconds. Partition table, while the latency is to be taken care of as a 631 seconds over the time. But only in the Stinger platform, so the latency is to be only 4 seconds over at a time, because with HTTP 2.1, the Stinger initiative that is completed, and it was being taken in mind to schedule with Apache Hive, Apache Tez as pre-launched hot containers. It has been optimized with vectorized query execution. ACID framework supportability is being added for managing dimension tables and other master data. It has got support for additional SQL functions and operators, and also it has got support for data accessing using HTTP, SSL, Kerberos authentication protocol. So these improvements to Apache Hive through the stringent initiatives in Hortonworks, it's been delivered order of magnitude improvements in query latency, and it pushed several types of queries in past 100 times faster than compared to older versions of Hive, that's 0.110. So speed, actually it has been taken in mind that in HTTP 2.2 introduced several major new performance features that could benefit for small reporting queries to deep analytical queries, like for Hive 12 query optimizer planning has been uh, released there, which optimizes the Hive's MapReduce plans into eliminate the redundant work. Complex queries can run 2 times more faster. It has been included predicated pushdown, so that to filter out the records at the storage layer rather than in the SQL engine. WRC file inline indexes has been released out, so WRC file maintains the specific indexes in line with the actual data. So combined with predicate pushdown, queries can skip the entire blocks and speeding the queries to be a suitable dataset by 50% or more. And currently, which is right now in GA version, that in general available stage, the vectorized query execution on Tez. So vectorized query execution basically batches the operations in the way that is very efficient on modern processor, and also vectorized query executions it speeds up the query processing by 10 times to 30 times to be more faster. So typically right now in the roadmaps for Hortonworks, like it being looking forward to expand use of the CBO, that cost-based optimization, by using a joining algorithm section selection and Tez checkpoint selection for temporary tables like session lifetimes and sharing intermediate results, materialized views by pre-compute common results or aggregations, transparently route via CBO, joining and grouping with respect to sort, because Tez also decouples algorithms from the data transfer, sort merge buckets in Tez, so to leverage the vertex manager, collocate the partitions on HDFS, and inline sampling and range partitioning with Tez, like sampling, creating histogram dynamically, that's for skew joins and total ordering sort. So actually WRC file, it was introduced first with Hive 0.11 in the initial earlier version, and it offered an excellent compression delivered through the number of techniques, like including runt length encoding, dictionary encoding for strings, and bitmap encoding like this. So these improvements that mean for sustained query times, like from Apache Hive 0.12, it provides a sustainable, acceptable query times even at petabyte scale. And it has also got a smaller footprint, like better encoding with WRC file in Apache Hive 12. It reduces the resource requirements for a cluster. So if it is encoded with text, so it original cases, like if it is encoding, suppose the footprint was suppose more than 500 gigs. So when WRC file which is being encoded, so it has got 78% smaller compared to text, RC file, perquet file, and ORC file. So larger block size, that means columnar format arranges those columns adjacent with the file for compressions and for faster execution. Um, Also, just another line to add, Tez not only works with Hive or Pig, Tez is also as being delivered with the platforms on HDP itself, like on cascading. Cascading, like it's a framework for parallel data executions that's on Apache Hadoop framework, and Tez has been added a significant improvement over there as well. And also Datamere is a company which already has been provided a support of Tez, just being as an integrated part of Apache Hadoop platform. So it's a vendor-specific platform, very specific for Datamere Hadoop itself, but it has they have already added Tez as an integrated component of Hadoop cluster itself. So there is a lot of information that's being available on Hortonworks tutorials and from the Hortonworks document. So I will provide some of the very important documents, and the process for query executions for CBO, that cost-based optimizations, and for distinct phases of examination like parse and validate query, generate possible query execution plan, a logical equivalent plan finding and assigning the cost, selecting those plans with having the lowest estimated cost. So those are the plannings being available, and query optimizer challenges like for the specific types of algorithm designing for supposing trees like left deep or bushy left deep trees, this corresponding optimization that's being available. Now some of the new CBO optimization have been added in Hive 0.14, that in 0.14 of HDP Hive they have introduced a new query optimization, like there are 3 techniques that's being added, like join ordering optimization, bushy join support, and join simplification. So we'll be seeing in some of the demos that what are the capabilities have been added. Now let's first start with the hands-on side. In the first demo, what we'll be doing, we'll be checking up the performance improvement of Hive over Tez. So what I've did, I have just opened the sandbox and just intended to open the Hue from there. So if I open the Hue on the port number 8000 and the IP address of the sandbox, so I'd be just click on Bvox on the Hive UI. So I'd be able to see this following screen, that from the table to create a new file, to create a new table from the file, and the data set that I'll be using for the demo would be available in this URL. So this URL, I have just taken out the data, the sensor file data, and now after taking out the data, what I'm able to see that there are actually 4 files being available, some of the CSV data files. So let's firstly go straight and to create the file. So I'm intended to create the file that's name as HVAC, and because I have 2 different CSV files available for the tables, that's HVAC and the building. So I'm just right now creating a new table from the file. Here I can select a delimiter for the table. So the data is actually comma separated. So I can keep the delimiter as comma. And next I can define the column types. So now here, as I'm able to see that the columns along with the corresponding data types has already been mapped. So what I can do, since the column names and the corresponding data types has been mapped, so I can click on create table.
Yeah, Nandita.
Yeah.
Well, we have a production call now. Can we have this class tomorrow? Can we continue this tomorrow morning?
Okay, fine, no issues. So I'll be creating the two tables, and then we'll be starting
Okay.
tomorrow from here itself.
Okay. Thanks,
Okay.
Ananta.
Sure. Thanks. So tomorrow's documents and resources I've already shared in tomorrow's class folder. In today's class folder, and the demo will be taking from today where you have just left off, and I'll be just creating the two tables, HVAC and building, and tomorrow we'll be taking up from there itself. So if you have any questions, any queries regarding the session that we covered, you just can let me know. Otherwise, I think we're running out of time, so we can wrap up. Okay, guys. Thank you then. Thanks for your time. We'll be meeting again tomorrow.